Oh, you absolute legends. Let's draw the Lewis dot structure for NO2 with a negative charge and determine the molecular geometry of that small molecule right there. Getting our total electron count from the valence electrons, nitrogen brings 5 to the table, oxygen each brings 6, so that's 5 plus 12, 17, and we have a negative charge. So that means that there are 18 electrons total in this Lewis dot structure where we can't have any more or any less. We should start with the nitrogen in the center of that molecule. That's the hint right there. That's the atom written first. And it's also of the two types of atoms, it's the least electronegative. So those are two reasons for it to start in the center. It's the atom written first, and it's the least electronegative. Our first prediction, or our simplest prediction, is going to have one bond to all of the atoms right there, NO2. And now we're going to fill in our octets. So now everybody has an octet. And so now we're going to cycle back up to the first step and see if we have 18 electrons. Okay, so we have too many electrons in here. So we're going to update our prediction and add one more bond. So now our second prediction has 2 bonds over here and 1 bond over here. Let's check our octets. Everybody has an octet now. Let's make sure we have 18 electrons. We have 18 electrons. This is a good Lewis dot structure for NO2 with a -1 charge on here. This two-dimensional static picture doesn't show the geometry around the central atom as best as possible. So let's kind of look at this central atom here, just the central atom here. The central atom here is surrounded by 3 things. And I say things just to keep it very general, because there's one thing over here, one thing over here, and one thing over here. Doesn't matter that there are 2 bonds, there's just one thing over here. Now, those 3 things that are poking out of the central atom dictate the geometry. Now, 2 of those things are bonds. And one of those things is a lone pair. Now, the 2 bonds that are present in this Lewis dot structure would give us a structure that looks something like this out of the model kit. This molecular geometry here we call bent. Anytime that central atom has 3 things poking around it, 2 of them are bonds and 1 of them is a lone pair, it is going to form this bent molecular geometry right here. Now, the electron domain geometry will be trigonal planar. The electron domain geometry involves all of the things that are going around there. It's really confusing, I think, that we talk about these adjectives, these descriptions of the shape, bent, linear, tetrahedral, to describe the molecular geometry. Molecular geometry doesn't describe the lone pairs on the central atom, and the electron domain geometry does describe include the lone pairs that are on the central atom. I hope this helps. Thank you.